All right, welcome back, everyone. Again, good morning, good afternoon, good evening, depending on your time zone. I am delighted that my good friend Mark Heckler, at the last responsible moment, has joined us here today. And I'm still trying to figure out how Mark got into my track exactly, but it's fine. It's fine. We'll work it out. We'll do it live. There was a brief moment of panic where Rohit and I were prepared to step in and attempt to give this presentation, which we both agree has a fantastic name, Mark. So good on you there. Game of Streams. I mean, what a wordplay there, my friend, because you are a GDP. So I'm going to go ahead and get out of your way and let you deliver what I know is going to be a fantastic presentation. So, my friend, take it away. Enjoy.
Well, thank you. First, can you hear me? Can everyone hear me? Okay. Um, I'm hoping that's a yes. If not, please tell me. Please raise your hands. Just kidding. Okay. So I'm going to, I guess, share my screen now at this point. Um, hopefully that will work. We've had some, or I've had, I should say, some interesting, some Zoom quirks this morning. But again, this is technology, right? This is why we love this field. This is why we go into this, because everything always works perfectly. Kidding. We like to find problems and fix them. So here we are. All right. So time is short, and actually, with the anticipation of all the things that I wanted to show you, I'm going to try to move through fairly briskly, but I don't want to go so fast that I just pin you to your seats and you walk away wondering what came of this. I want this to actually be a good, useful and productive use of your time, even if I am in the architecture track. Just kidding, Nate. But no, I think this is super useful, and I want to make sure that you come away with more than you walked in with. I always do. I always feel like I learn something every time I present something. So welcome. Yep, game of streams, because I feel like why not, right? We are dealing with dragons at times. What I like to say is just how to tame and get the most from your messaging platforms. Most of us have messaging platforms within our organizations, and most of us really are probably underutilizing those messaging platforms. So hopefully we'll walk away today with some food for thought, and you'll maybe have some ideas on how you can make the most of your investments that your organization has already made, and do some cool things while you're doing that. As Nate mentioned, my name is Mark Heckler. I am a professional problem solver, not officially. That's just unofficially what I do. It's what you do. That's why we probably all got into this field, because we like to find things that are broken and fix them, or find things that are working and make them work better. Right? I am a Spring developer and advocate. I love to write code. I love to talk about writing code. So this is kind of my ideal gig. It's what I love to do, to chat, to in a different time, grab coffee with folks and just pour over code together and pair together. But we'll still do that. We'll just do it a little more distantly in a virtual manner. So if you have any questions, comments, or feedback, what always happens to me is 10 minutes after I walk out or click off of a session, I think of something that I meant to ask or wanted to bring up. By all means, again, that happens to me all the time. If it happens to you too, that's great. Just ping me. Email is available. These are the two email addresses that I check the least infrequently. I don't live on email, but I do try to pop in from time to time just to make sure the house isn't burning down or something. But the best way, the level best way to reach me is always, has always been, probably always will be, on Twitter. If you're not following me at MKHeck, why? Kidding. But please do follow me. Send me any questions, comments, or feedback. If you don't want to share your questions, comments, or feedback with the whole world, my DMs are open. So direct message me. That's perfectly fine. If you follow me immediately and I haven't even seen that yet, you can still DM me and I'll get that. So yeah. So how many of us, how many of you have your bosses come to you at the end of the year and said, you did a great job this year, but you did a little too much. What I'd like to do is double your budget and have you slow down a little bit. Yeah, probably none of us. And if you have had that happen to you, please do let me know. I'd like to write up a government grant proposal, because that's something that's very unusual, and it'd be good to capture that and document that. Typically, what happens is that we are always asked to do more with less, or at the very least do more with what we have, right? And that's kind of where I wanted to come from with this talk because very few of us actually fully leverage, fully utilize the resources at our disposal. And it's kind of a very powerful thing to take something that we already have and really expand its capabilities, or maybe even move into an area that's complementary and expand the capabilities we can provide for our customers, right? By the way, I'm a big movie and TV buff. I love good quotes, love good TV shows and movies. If anybody knows what this show is from, I usually ask this of the audience, but I guess since this is a more one-way conversation today, I'll have to just supply this. This is from Parks and Rec. Our good buddies John Ralphio and Tom Haverford at their company, Entertainment 720. So anyway, that's free trivia for the day. But yeah, so we're going to talk about doing more with less, not less with more, hopefully. A little bit about myself. I am an author. I've co-authored a couple of books, contributed content and code to several other books, have another book in the pipeline, which I'll mention here shortly. I am an architect and developer by trade, and as you might surmise from the next point, where most of my expertise has been won, it's been in the JVM ecosystem. I am a Java champion, a Java 1 rockstar, a Groundbreaker ambassador, a Google developer expert in Kotlin. So yeah, it's all been, well, most has been in the JVM, and that's where I spend most of my days and have for some time. Happy with that too. Good choices. I am a professional problem solver, as I mentioned. I am a developer and advocate. I am also the sole creator and curator of Spring Noticias en Español. A couple of years, almost 2 years ago now, I guess, I felt like there really wasn't a centralized place to share Spanish language resources. So if you are a Spanish speaker, un hispanohablante, déjame extender tu voz. So let me share your resources with the greater Spanish-speaking Spring community, and we all learn, we all grow together, right? If you're not a Spanish speaker, that's fine. My English is only slightly better than my Spanish, so I appreciate your patience and hanging in there with me. I am also a pilot. I like to jokingly say that when all the planes stopped flying, commercially, I just had to start ferrying myself around. But that's not really the case. It was always a childhood dream. I started lessons a long time ago and eventually just wound up finally several months ago finishing off. I am a licensed pilot. People do allow me to actually fly airplanes. Crazy, the trust that some organizations and people extend. But here I am. So that's a passion of mine. And I'll be actually tying that into some of our examples here as we go, because why not, right? Real world is always more fascinating than artificial constructs, or would think. See Sir Arthur Conan Doyle for that. Okay, so the new book. I am under contract with O'Reilly to write Spring Boot up and running, building cloud-native Java and Kotlin applications. I'm almost done with it. Feels like I'm almost done with it, but I keep thinking of more things I want to add because I just don't want to stop. At some point, I will have to stop and actually publish. Probably, I think we're looking at November timeframe for actual release. If you're interested in checking out for free early access the first few chapters, go to bit.ly Spring Boot book. Check it out. O'Reilly gives you I guess a limited time access to start reading through the first few chapters, and follow at Spring Boot Book on Twitter for release information. But yeah, that's where I go into things and explore even further Spring Boot concepts using Java and Kotlin. Some of the things I'm going to be talking about today, because I like to tie it all in because the Spring ecosystem is so rich. Yeah, so check it out if you're so inclined. But today, I want to cover 4 basic things here. Why use messaging platforms? Where do they fit in a distributed architecture? Some examples, what is Stream? Why use it? Let's start with the top one first. It's always a very good way to kick things off. I like to go back a little bit in terms of history and talk about how we got here from there. In the old days, you typically had monoliths, and we still have monoliths, right? Monoliths do a lot of they run a lot of critical capabilities, provide a lot of critical capabilities globally, and that's a good thing, right? Monolith is not a bad architecture. Monolithic architectures, like all tools, like all constructs, have trade-offs, right? So they have ups and downs, they have pros and cons. And the big thing, I guess probably the biggest limitation of monoliths is their scalability. A lot of times I like to, just my approach is I like to kind of build an example and then build out from there, and it kind of makes a lot more sense metaphorically to me. So let's say that we were going to create an online retail establishment, and we won't want to like infringe on anybody's trademark, so we'll call it Amazon because there's nothing like that out there in the wild. So let's say we're creating Amazon, and we're going to create this monolithic architecture because we don't know how big this is going to be. Maybe only 5 people will buy stuff from us, maybe 50, I don't know. So we're going to start very small with a monolith, and that should do it. But let's say that it kind of takes off, right? So people start ordering, and we have a lot of capabilities, a lot of modules within this monolith. So we have an order taking capability, but we also have to have an account creation capability. And within the order taking, once they create an account and they start browsing, they have to look at a catalog. And when they choose an item, we have to have an inventory system or an inventory module that ties to, and says, well, they want one widget. Do we have one widget in stock? Do we need to reorder? They have been reordered. We're out of stock. When will they arrive? We should have a finance package so that when they enter their credit card information, or when they go to pay, we can check to see if the credit card is authorized. We should have a shipping and logistics portion, so we can say, do we send this out via FedEx or UPS or DHL or what have you? So we have a lot of different modules within that monolith. We also typically have a returns module because, people do get stuff. They say, well, I didn't order blue, I ordered black, so I want to ship the blue one back and get the black one, and that way I get what I want. It happens. So you've got all of these modules within a monolith, and that works pretty well for a small set of users, right? But let's say we don't just stop at 50 people. Let's say we have 500 or 5,000 or 5 million customers, and we look at that and we think our monolith is just falling over. How do we scale this? So we realize pretty quickly that the fastest, easiest way to scale is to just pick up that monolith and create a second monolith, and ignoring all the things in terms of distribution and of the load, and in terms of making sure we don't have contention in terms of updating certain things like orders and inventory. Let's ignore that for now. And let's just say that we pick up our one instance of a monolith and instantiate another instance, and we have 2 now running, 2 monoliths. So they're running side by side, and we've roughly doubled our capabilities. What are the problems with that? Well, the problem is we're taking along a lot of dead weight in most cases. Let's use the example of Black Friday. Black Friday in the U.S. is it's where all retailers typically say they go into the black. So they get out of the red where they're losing money all year. But as of Black Friday, they start making a profit. And everything from that point to the end of the year is in terms of the overall revenue versus cost, is profit, right? So when Black Friday comes, they're getting hammered. There are a lot of people who shop online and in person. Well, probably not in 2020, but there are a lot of people who shop online and who go online to buy things on Black Friday. And that's what retailers count on. That's a grand and glorious thing. How much do you think that the returns module is used for an online retailer on Black Friday? Almost none, right? Because they'll use that later, right? They'll get the wrong thing, or they'll decide, buyer's remorse, whatever. But on Black Friday, the order module, the inventory module, the payment module, those are used a lot. But the returns module is used almost not at all. And if you've done a really good job in terms of your selection and your target market, your product market fit, maybe it's not used a lot anyway, but it's certainly used a lot less on a big shopping day. So when you scale the monolith, you're bringing along that module, which doesn't need scaled at all, but you're bringing along, you have to. It's part of that monolith. So you have some limitations in scaling. So what we typically do when we look at that is say, well, there has to be a better way to scale. How do we do that? So we start looking at ways to divide that monolith and tease out the functionality that we need to scale, that we really need to scale this and this and this, but not that, right? Which leads us quite naturally into an evolutionary path of microservices. So we look at microservices, well, this as the solution. We start saying, well, our order module, that's going to be very heavily used on Black Friday. So we'll separate that. What we start to realize, though, is that even within that realm, there are some limitations, because we're not just teasing out a microservice, because as I mentioned, when you go in to order something through Amazon, you will hit the catalog, you will place something in your cart, you will check inventory, you'll process payments, and all these things are kind of taken as a whole. So they rather, some of these things kind of need to scale together, right? And we find typically that when we scale those out, we're not teasing out a microservice, we're teasing out a small cluster of microservices. We also see that scaling wise, when you scale up the cart module or the catalog module, you'll probably scale rather linearly some of those other modules as well, because if you have 100 requests going out from your inventory or from your catalog to your inventory, you probably, if you have an instance of your catalog managing those 100 requests, you'll probably have an instance of your catalog or your inventory module that is interacting with an instance of that catalog. So you find that even when you start teasing those microservices out, you're not teasing out a service, you're teasing out a small collection of services. Not necessarily a bad thing, it's just something to be aware of. So then we start looking at how do we do that? Well, typically we start with an HTTP-based interface, REST APIs, what have you. And that does, even within that realm, you still have the advantages when you tease out that functionality of increasing your development and deployment velocity, because you're not having to retest, redeploy everything at once. You can tease out the things and test those and develop and deploy those independently, which does help, right? But it's not quite as isolated as perhaps you might have hoped. And the scaling is, as I mentioned, with an HTTP-based approach, a little more linear than maybe what you'd hoped or planned. And that's where you kind of get into that requirement for next level scaling. Because when you have a messaging platform, you have unequaled scalability and flexibility. You can decouple temporally. So if you have a capability, a service that sends a message that says, hey, I want to do this, it can be online, and perhaps even the receiving service may not even be online when that message is sent, depending on how you define your pipelines. And I try to stay at the higher level in terms of terms, so we're not talking a specific technology yet, but how you define your pipelines, those durable pipelines where they can be sitting there waiting for you. So at some point, if the consumer of those messages comes back online, maybe the producer of those messages is no longer even there. That's fine. It just knows, that consumer knows it has messages to process, and it comes back and it processes them, and life moves along merrily. So you can decouple temporally. You can also decouple locationally or numerically, because if a producer produces a lot of messages, a lot of requests going out, maybe your consumer actually can't keep up. Maybe there's a lot of complex processing that's on the back end. So instead of having 1-to-1, you may have 1 to 5 or 10 or 50, and that can be adjusted as demand varies. Locationally, of course, it doesn't necessarily, the consumer doesn't have to be in the same place as the producer, doesn't have to care where the producer is or where the message came from. It just sees it as a message to consume. You also have practically unlimited routing variations, very well established patterns. Maybe you have a pattern that hasn't ever been seen before, but you can define that due to flexibility in routing with messaging platforms. It gives you a lot of capabilities that you don't necessarily have when it comes to direct interactions. Okay, so some examples. I mean, there are numerous. There are, well, probably innumerable examples. I like to kind of bubble it up to the top handful, at least in my mind. You have RabbitMQ and Apache Kafka. Those are probably the big entries in the field. They're well established. They're well tested and proven. They are able to be deployed and used, everything from a laptop, a container, all the way to a hosted environment, in-house, cloud provider, doesn't matter. You have ultimate flexibility. You also have, among all the major cloud providers, several entries typically for each one of those. So you have things like Amazon Kinesis, Azure Event Hubs, Google Cloud Pub Sub, and many others. Even within each of those, I just like to kind of boil it, bubble it up to the top level and maybe choose a favorite on each platform. Among those, that Amazon, Azure Event Hubs, and Google Cloud Pub Sub, those aren't open source. That may or may not be a big concern for you, but it may. So I like to point that out. RabbitMQ and Kafka are 100% open source. And again, they have a lot of history behind them and well-established traction for good reason. Again, doesn't make them the leaders throughout in every use case, but I like to typically think of them first as kind of being the category leaders. And all of those that I mentioned and many more are supported by Spring Cloud Stream, which brings us, I guess, to the next level, which is, what is Spring Cloud Stream? Well, I'm going to pause to drink some coffee and and soothe my soul. I actually have coffee and water here, water to soothe my throat, coffee to soothe my soul. So, we'll see which one needs more. Right now, the coffee sounds great. But what is Spring Cloud Stream? Well, if you can standardize on one messaging platform, and it did everything you needed, and you could push that out through all of your organization, all your vendors and partners and customers, that would be amazing. But typically, there's always some integration work, right? And even if we can standardize within our organization, the problem is as soon as you work with a partner or a customer who has a different solution, or as soon as you are acquired or your company acquires another company, you're back in the integration game. So if you've standardized on Rabbit, and then you switch to Kafka, or if you're standardized on Kafka and a company you work with uses Kinesis, it would be really nice if there was some way to make the mismatch go away, or at least to reduce the pain of that dramatically. And uh, what we find as developers is that there are a few times, and of course, when you first configure things, that you need to actually get under the covers and tweak things a little bit and set up configuration settings and whatnot. But generally speaking, as developers, once we have things tweaked the way we want them, all we care about is pushing messages into a pipeline and pulling them out of that pipeline and doing something with them, passing them on to another pipeline, picking them up, doing the same thing, and eventually consuming them at the end. And that's the life cycle of the message. We care about the pipelines. We care about the transitions, the transportation of those messages. We don't necessarily care about the specifics of it, right? Doesn't mean we don't ever care. Doesn't mean we don't need to get to some of those things. But generally speaking, we care about making sure the messages are where they need to be when they need to be there. And Spring Cloud Stream allows us to abstract from that, to step up a level. You still have access to all the underlying configuration tweaks and settings for any individual underlying technology, but you don't have to get into the plumbing. In most cases, you can take that at a more abstract level and look at how to connect the dots, connect the modules, if you will, the stopovers on the journey home. So Spring Cloud Stream is built on Spring Boot. It was originally kind of created around the idea of Spring integration, which allows you to integrate various different components. Spring Cloud Stream focused and still focuses on the messaging platforms, but with the newer, what I consider to be the evolved and evolving API, Spring Cloud Stream allows you to take things in a much more clean and pure way. And by saying that, I nothing wrong with the existing legacy API at all. It will be continued to be supported for a long, long time. But what we saw is that there was a little bit of abstraction leakage here. And if you were familiar with Spring integration, it seemed very natural. But when you looked at Spring Cloud Stream, it seemed like there might be a cleaner way of doing things. So that's kind of where we're headed with this. And I'll get into that momentarily. So I use it again. It allows you to focus on the things that you need to focus on, to not get into the weeds when you don't need to, don't want to, and to give you ultimate flexibility when it comes to providing the solutions you need to your customers. So again, if you, pardon me, if you're in the situation where you may need to be a little more flexible with your underlying architectures, your underlying messaging platforms, to be able to integrate with multiples, you need that flexibility. You don't need to always be worried that somebody's going to find an article, read it, and change your world on you. You need to be able to have that flexibility in your architecture to still keep the valid and valued business logic and work with whatever is allowed to be worked with or provided or best option for you to use, and not have to completely retool and refocus your brain. It should work for you, not the other way around, and that's what Spring Cloud Stream does. So I actually based this talk on a wildly popular talk from last year that I had given, and I initially had started with just 100% code. And I had a great time. The feedback was good. But what I found is I was getting a lot of the same questions. So just like Spring Boot, in terms of finding and isolating repetitive tasks and streamlining them and making them convention over configuration, making them where it's you make things easy. I wasn't doing that, so I wanted to provide a little context and isolate the repeated questions and provide some of those answers up front. So hopefully we all understand more and get more out of it. So what I'm going to start off with in terms of the code is using Spring Cloud Stream in some messaging platform. I'm going to use Rabbit because I like Rabbit really well. If you're a Kafka fan, that's great. I'll use Kafka too. I do want to say though that I mean, typically we try to boil things down to the simplest thing. So we say, well, Rabbit's ultimate in scale or flexibility in terms of routing. Kafka is the ultimate in terms of performance, right? In terms of throughput. Uh, there's nothing necessarily wrong with Rabbit. There's nothing necessarily wrong with Kafka in either of those contexts. Pivotal and Google, back when it was Pivotal and Google, did a test and found that they could scale Rabbit to the point that it was almost 3 times the number of messages in a day that were processed in the US for WhatsApp, iMessage, and SMS messages total. You can scale Rabbit to handle almost 3 times the volume per day that were produced per day. So not insignificant, right? So Rabbit's got some crazy scalability chops, crazy throughput. Kafka's no slouch at routing either. They each have their own strengths, but they're certainly not weak in other areas either. So you have, again, flexibility. I like to start with Rabbit because, again, it is well tested, well proven, and it gives me, start somewhere, right? And then we'll play with Kafka as well. But the examples that I typically will use are to create 3 different things, right? Different services. One is a source of value, so it produces values. A processor will pull those values off, manipulate them, transform them in some way, and then send them on to another pipeline. And then a sink will consume them. And that's the end of the route for a particular message, right? When the sink processes it, that's the end of the life cycle for that message. And these were defined interfaces in the legacy API of Spring Cloud Stream: source, processor, and sink. Source creates values, sink consumes them, processor transforms them. And what we realized is that these correspond and correlate very well. I'm kind of getting ahead of myself. Let me back up here. So these are the 3 different interfaces that are defined within as predefined interfaces in Spring Cloud Stream. You can create your own. You can create any number of different stopovers and different configurations, different interfaces you can deal with. But composing these 3 into various different combinations gives you a lot of flexibility. You can scale these too. I just show it scaling more to the right, but obviously you can scale your sources and processors and sinks to any way you want to or need to. But you can create groupings or groups, consumer groups of each of these, and allow you to scale out to or scale back in to adjust to demand. You can also swap out your underlying pipelines. So that gives you the option to, if you do need to change your underlying messaging platform, you can do that with the least amount of trauma possible. Just amazingly easy to do. And then, of course, if you need to integrate those, as we often have to in our worlds, right? It makes it very trivial to do that as well. So again, source, processor, and sink, these are valid concepts and they make a lot of sense, but they also have parallels even within Java, right? So a source, processor, and sink roughly correlate to a supplier, a function, and a consumer. And these are interfaces defined in Java. A supplier does the same thing as a source, right? It produces values. A consumer consumes values. It's like a sink. That's the end of the line. A function transforms values. It's the transformative function in the middle. So we started looking at this and how we can make this more like regular plain Java and less like a Spring integration specific type of construct. And again, doesn't mean you can't use the legacy API. It works perfectly well. It's great. It's flexible. It's clear. But this is kind of the way forward. And I like to show you kind of where things are heading. So, and if we have time, a few kind of nice, useful bits and bobs, if time permits. But if not, please start the repo. So let's code. Let's get into this. So this is our friend Maurice Moss from the IT Crowd. If you haven't watched the IT Crowd, you're missing out. Please do watch it. I think it's still on Netflix. If not, find it. It's well worth seeking out. So, okay. Time for another hit on the coffee. All right. I always feel a little bit bad, like when I drink coffee and if I have to go to the store or something, and of course you're wearing a mask and that's fine. But after you drink enough coffee, it's a little bit of an astringent property, so it makes your throat a little drier. So then you cough a little. And then I always feel like people look at me like, oh my gosh, he's diseased. I'm not, I just can't give up my coffee. So, all right. So let's go to our Spring Initializer. This is your starting point for Spring Boot-based microservices on the web. You don't have to go here. You can actually curl the API. The initializer exposes an API, and that's fine. You can HTTP it. You can access it via your IDE, as we did in the workshop earlier, the Spring Boot workshop. It all produces the same artifacts, right? Which is good. Consistency is very important. But I like to go to the Spring Initializer for a couple of things. It's just a really nice interface here. It allows you to go light mode and dark mode, which I think is brilliant, because if you are 100% dark mode, this is a little that's kind of a wake-up call. I guess if you haven't had your coffee yet, it's not a bad thing. If you're 100% light mode, you wouldn't want to go to this, but it lets you configure that and stay within that. It also gives you the ability to explore a project, and hopefully I'll remember to do that before I just create it, because I think that's an extremely valuable, it's a small feature, but it's an extremely valuable small feature that I use all the time, and you probably will too. So I'm going to just today create 3 different services: our source, our processor, and our sink. I'm going to tie them together, and we're just going to see what happens and how much time we have to go through this. You have options within the Spring Initializer. If you're a Maven developer, you can use Maven for your build system. That's great. If you're a hipster, you can use Gradle, so that's fine. I'm not feeling the hipster vibe today, so we'll just go Maven. I'll stay with Java, but of course you can use Kotlin or Groovy. For whatever reason, when I do Kotlin, I use the Gradle project. I use Gradle for my build system, probably because that lets me do a Gradle.build or build.gradle.kts, Kotlin script file for that, which is a small feature, but nice. I'm going to use the current version of Spring Boot. I'm going to change this group to the Hecklers, because why not? I can't even spell my own name though, so maybe I do need more coffee. And I'm going to create a source here. And then I'm going to create a jar, use jar packaging, which allows me to self-contain and bundle all of our dependencies in one thing. I'm going to use Java 14 because why not? And then I'm going to bring in my dependencies that I want to use for these projects. So I'm going to bring in reactive web for a dependency. I'm going to just go with reactive because our time is rather short here, and I want to make sure we get through as much as possible. But the imperative code is very, very similar. I have the code all out there in the repos, so please do check that out. But the reactive I'm going to kind of focus on today. I also want to bring in Actuator because it has some nice capabilities. I like to use it, especially with streaming apps, because that lets you kind of peek in and see things. But certainly any production-ready application, that's where you go, is Actuator, right? I'm going to use Lombok because I'm a lazy developer, lazy good, not lazy bad. I just want to be very clear about that. Lombok, as it says, it helps reduce boilerplate code. It'll actually create your getter, setters, equals, hashcode toString, constructors, what have you, per your directions. So if you want to have your ID generate them or handcraft them, certainly you can. Artisanal getters and setters are a thing, but I like to focus on the business value, and Lombok helps me cut through the clutter and do that very quickly. So I also want to bring in my dependency for Spring Cloud Stream. And as you can see, it says this is a framework for building highly scalable event-driven microservices, blah, 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 requires a binder. Examples: Apache Kafka, RabbitMQ, or Solace, PubSub Plus. So it tells you if you're going to use Stream, you're going to, whoops, you're going to want to also bring in a binder. So I'm going to actually bring in 2. I'm going to pretend I can't make up my mind. So I'm going to bring in Rabbit, right? And I'm going to also bring in Apache Kafka. So that should get us up and running, I think. Now, I want to explore this because, again, I think this is very useful. This lets you see exactly what you get before you get it. So I see the dependencies that we're going to create in this project or use in this project, and that's extremely useful. If you've created a project, you forgot a dependency, sure, you can, if you have it memorized or if your code completion is keeping up with you in your palm, that's fine. But if you just want to go and see what you've missed, this is a quick and easy way to do it. I think that's kind of nice as well. So let's generate this. I'm just going to drop that on the desktop. We'll call this source, and just in the interest of time, I'm going to create a processor, and we'll do the same thing, dump that on the desktop, and we'll create our sink, and same thing. All right, so now just to open that, come on. There we go, source, and I'm going to open that in my favorite IDE, NetBeans. Just kidding. I like NetBeans. I pick on my friends, so that's not meant to be a slam at all. I use IntelliJ because it fits best with my workflow. Of course, I use Kotlin, and Kotlin works best with IntelliJ because the JetBrains folks, lead the development of both, right? IntelliJ and Kotlin. But Eclipse has great Spring support. NetBeans also. You can even use Vim. Just please don't use Emacs. Have some self-respect. Kidding. Emacs isn't, I guess, all that terrible. VS Code also has a language server that we provide that has some great capabilities as well. But IntelliJ is just kind of my thing. So, all right. So let's start off here. If we go and look at our POM, of course, we see that this is what we expected to have. Here are all our dependencies. Nothing new really to see there. So I'm going to go and open my application properties because we'll need to do something with that here shortly. Nope. And then I want to open my application. All right. So here's all the code that's created with the Spring Initializer, your main application class, main method. That's it. But it does set things up very nicely for you to start and be immediately productive. So what I want to do for my example, because there's always this struggle with what to do for an example that feels real world, right? And for a long time, those of you who know me know how much I love coffee. I would use only coffee examples because they gave me energy. But I don't know. I couldn't find a way to make that feel more real world that was actually tying into real data. Real data is much more fun because you see it coming in, you see it hitting, and it's real, right? It's not contrived, it's not generated data. So I thought, well, I'm a pilot. I'm also an aviation enthusiast. So I have a little device that I've created with a Raspberry Pi that allows me to pull in the locations of any aircraft in my area, right? This is a fairly common thing. There are multiple sites you can go through to get this information and feed that information. And that's what I have is a little device that just checks around the area and says, hey, this aircraft's in the area or these aircrafts. And that's what I'm going to be using is real life data for aircraft in the area. So hopefully we aren't, of course, before 2020, you had a lot. Now you just hope you have a few that are flying over at that point in time. But I'm going to create a class called aircraft, and this is really an aircraft positions class, right? So this is what we will be using for our domain. So what I want to do is create a few things. So we have some member variables. So we have a let's see, we have a call sign and a flight number and a type. Let's see, a registration, right? So we have a registration. So our reg and our type. We also will have integer for altitude and speed, heading, and speed. We'll get that in there. And then we have some lat and long. So we have our position information. So this is the information we'll be getting when we query our little device that actually says, hey, here are all the aircraft in the area. I'm going to use Lombok again. So I asked Lombok to provide me our getters, setters, equals hash code 2-string with the @data annotation. And then I'm going to ask Lombok to provide an all argument constructor for me. So this will create a constructor with a parameter and argument for each of our member variables. And that should do quite nicely, I think. Okay, so this is our source. This is the thing that actually we're going to be pulling the data from our little device, but we also want to push this out via our messaging pipelines to any consumers who may want to use this. So I like to create a configuration class, and this will be our position feeder. And I'm going to create a bean, or I would create a bean. But in this case, what I want to do is poll every so often. Typically with Spring Cloud Stream, if you're dealing with imperative types, you would do a bean and you would create a supplier, and that supplier will check for updates every so often, and that's definable as well. Since I'm going to be using reactive publishers, but I'm going to be getting a flux, a publisher of 0 to n values, but I'm going to be getting that, and then I'll be polling again. I need to create this as a pollable bean. So I'm going to create a supplier. If you don't understand that, by the way, ping me later. We'll talk about it at length. That's perfectly fine. And I'm going to create a supplier that supplies a flux of aircraft. Right? Here we go. And we'll say the send positions. And a supplier is what? It's a functional interface. And of course, we have a single abstract method, which can be supplied with a lambda. So we're going to do that. Now, I need some way to create this lambda. I need some way to poll my device and pull those values in. So I'm going to create a web client here equals web client.create, and I'm going to access that device on my network, localhost 7634, and the endpoint is my aircraft endpoint. Remember my semicolon, that's the hazard of switching back and forth with Kotlin. So here's back to my supplier, here's my lambda. So I'm going to use my client and get. I'm going to retrieve a value. I'm going to convert the body of that value to a flux of type aircraft, right? And I'm going to filter because I may have values in which the registration is empty. Yeah, so we don't want that. We don't want any empty registrations. And then we will, well, let's just log this. Yeah, so that should work, right? Yeah, that seems like that should work. If not, we'll always think it should have. And we'll come back to that later. So we have our supplier here. We have our source. We just need to provide a little more information to Spring Cloud Stream so it knows what to do with that. So for starters and for boot, the default is 8080, but since I'm going to be creating 3 of these services, I can't have them all go to their default port. And of course, I can define 8081 and 82 and 83, or I can just set this equal to 0, if I can hit the 0 key. And that tells Spring Boot to, upon initialization, look for an empty port, an open port, and just use that. And that'll be fine for our purposes. I also want to set up the default binder. Now, I don't have to set a default binder. I can define a binder for each of my destinations. But in this case, I'm going to just set this at the top level, and we'll use this and assume Rabbit for everything. You don't have to do that if you only have a single binder here. But if you see here, I have 2. And this is what I was saying. If you don't give Spring Boot enough information to auto-configure things for you, it will prompt you and say, look, you included 2 binders. Which one should I use? In this case, we're providing that bit of information that's needed so it knows what to use. So we also want to set up our bindings here. And with the new API for the evolved API, if you will, for Spring Cloud Stream, we can set up our channels in terms of our functions here. So we have a bean here. The function name is send positions. We have input and output channels, but since this is a source, it only has output channels, right? And we only have 1 at this point, but we can define up to 8. We don't need 8 at this point, so we'll just stick with 1. We'll set the destination equal to a pipeline we'll call processor, right? And then let's see, we will probably want to switch to Kafka at some point. So I want to set this to auto add partitions for us so we don't have to worry about that. Set the minimum partition count as 4. And I don't think I'll have time to show you Actuator just the way the time is shaping up, but just in case we do, I'm going to add this. So we open up all of Actuator's endpoints. I will say this, please do not do this in production. So this is kicking down the doors. This is basically disabling all security and exposing all Actuator endpoints to anyone. You don't want to do this because it exposes a lot of information that's kind of important information that you don't want an attacker seeing. However, for demos, what this allows me to do is instead of granularly opening or excluding different things to be able to see, this lets me see all endpoints. So don't do this in production. This is only for a demo. This is only a test. So that's our source, right? So let's go ahead and we'll create our processor and our sink rather quickly. So the processor works very similarly to the source. So we'll go straight to our application properties, server.port equals 0, Spring Cloud Stream. I'm going to go with the bindings. We'll come back to that, Spring Cloud Stream, Kafka. We want auto add partitions just to simplify our lives a little bit. So when we switch to Kafka, it's all good. And management endpoints include, again, not in prod. Okay, so that's good. So we'll come back to this. Let's go to our main application code. And wow, since time is rather tight, I'm going to do something that I'm a bit embarrassed by, but please don't tell anyone. I'm Good thing this isn't being recorded, right? I'm going to copy and paste code. So we have our aircraft here. Now this is our processor. This is our transformer. So we're going to transform, see if I can speak, right? Time for more coffee, I guess. We're going to transform aircraft into what I call essential aircraft, just the information we want and need to see downstream, right? So, and wow, since we are tight on time, I'm going to just copy paste that in. So, not proud of myself today. But so what I'm going to do is isolate our call sign or registration or a type. I'm also going to add a manufacturer member variable. And what I'm going to do is, based on the type, the first couple letters of type, I'm going to determine what that manufacturer is, and we're going to fill that in as we go. So here we have our configuration class again, if I can type, and this will be our aircraft transformer, and we'll create our bean, and this will be a function, right? So this is a function that takes a flux of aircraft and creates a flux of essential aircraft. And come on, IntelliJ, import that class. Happy. So AC transform. And let's see, so we're going to, once again, have a lambda, and we'll take in an aircraft flux, and we'll take that aircraft flux and we'll map each of our aircraft to a new essential aircraft, right? And we'll take our call sign. So what are our constructor parameters? Our call sign, right? And oops, mistype. And our registration and our type. There we go. Okay, so that's good. Yeah, so then we'll log that. That should be good. So we're transforming and logging this. Then we need to take our AC transform. Oops. Yep, that's good. And we will insert that here for our bindings. We have our input channel. This is a transformer, a processor, so it has an input channel and an output channel, or channels. And we're going to, once again, set our destination equal to what the pipeline name was coming in or coming out of our source, which was processor. Now, I'm also going to assign a group. If you don't assign a group and you scale out, what happens is that every subscriber, every service that's listening to the destination, in this case of processor, will get a separate copy of that same message. And if you want to implement the fan out pattern, that's how to do it, right? But if you're wanting to implement the competing consumer pattern, what you need to define is a consumer group. Now, why that's valuable is that allows you to scale, because if you create 2 or 10 or 20 different instances, different services that are within the same consumer group, they take turns, which allows you to scale and handle many more messages, or scale back in when you no longer need to. So we have our input channel, so our Spring Cloud bindings, Spring Cloud Stream bindings. We have transform output channel -0, and our destination here will pass that to a channel called sync. We don't need a consumer group on our output channel because it's not consuming, it's producing for our output channel. So that's fine. And that should be good. We can also, if we want to specify these separately, we can set up our binder, and this will be Rabbit, and same thing here. We just set our binder, and we can specify that separately that way. So that will be somewhat useful here later on. Let's go ahead and create very quickly. We have 7 minutes, tons of time. So let's open up our sync project. And once again, while that's happening, what I'm going to do is go here to our processor. Oops, that's our sync, our processor. And I'm going to, again, rather ashamedly, I'm going to copy this. Now, here's the different thing about this, right? Because I'm just going to copy part of this, so at least I'm not a total cad here. Because our transformer transforms aircraft to essential aircraft. It's only passing on objects of type essential aircraft, or a flux of essential aircraft. So that's all we really need to be concerned with when it comes to consumers, syncs at the other end of that. So here I'm going to do this. There we go. Why did that not do that? And at RX instructor. There we go. Much, much nicer. Okay, so that's all we really need to care about coming in here. Here we create our configuration class once again, and you can actually place any bean creation methods up here in the Spring Boot application, the main class, because if you drill into this, you can see that this includes Spring Boot configuration, which includes the configuration annotation. I just like to keep things separate because, of course, what I typically do in production code is not just dump everything in the same file. I create a separate file, right? A separate class file. And this allows me to keep things a bit more clean and isolated, but it's largely preference. So this will be our essential aircraft sync, and we'll have a bean here, and this is a consumer of a flux of essential aircraft, right? And oh, there we go. Yep, and we'll just log it. And so let's see, we'll take our return AC flux, and we'll do an AC flux dot subscribe, and we'll just print these out. Print line, that'll work. Okay, so I'm going to grab this. We'll go back here, server port 0, Spring Cloud Stream bindings. Actually, I'm going to do default binder, and we'll say that's Rabbit, Spring Cloud Stream bindings. And we have, of course, for a sync, for a consumer, we just have input channels, right? 0, our destination, we call it sync. We have a consumer group, or we could have a consumer group, so I'm going to define that here. And then, of course, for when we switch to Kafka, we'll set our auto add partitions true. Cloud Stream Kafka, minimum partition count 4. Management endpoints include not in prod, please. All right. Okay, so we're ready to go, or we should be. Let's find out. We'll start these up. Okay, we're up and running here. So we're connected. That's nice. We'll go to processor. We'll start that as well. Ooh, so tight. I should have asked for 2 hours. Okay, so let's go to our source. Not sure I would have gotten it, but it would have been nice to ask, I guess. Huh? All right, so we're going to fire up our source. And again, our source is polling my little device on my network, which grabs aircraft position reports active at the time, and then it sends them on. Oh, well, we actually have a small problem here, so let's see what I forgot. Oh, no creators like default constructor. Come on. There we go. But really, I should not need that. That's interesting. Let's find out. Oh, well, see, we have values here, which is good, right? We've got a couple aircraft in the area. And I did filter out if they don't have a call sign, because sometimes that's just a little annoying. So, and for whatever reason, that's not coming through here. Our manufacturer is not interesting. Okay, so, well, time being the way it is, so we're getting their values through at the very least. I could actually troubleshoot and fix that, but what I would really rather do is show you some rather cool things here. Because what I'd like to do is change this over the processor. We've got our sync listening on Rabbit. Let's just change this to Kafka for our processor on our input channel and push the values out via Rabbit. And then we'll go to our source and we'll do the same thing here. Kafka, and we'll restart that. And it's so hard to tell when it's the same couple of records that are coming through each time. But here we go. Yeah, so we've got our timestamp here, which tells us that we're getting the same records. And if we really want to take a peek here, we can see this. Oh, it looks pretty quiet out there. No wonder we're only getting a few. Yeah. Yeah, so some of these are not within range that can be reported, but sadly. All right. Well, with that, I would absolutely love to go longer with this. Can't right now. But let's go back to our slides and finish up there. So resources. If you want to see the code for this and more, the stuff we couldn't cover, like Actuator and doing the command line parameters, command line properties, updating and overriding what's provided in your application properties, check out the repo at Game of Streams Aircraft Edition. And if you're a Kotlin fan, at the bottom down here, we have Game of Streams Aircraft Edition in Kotlin, because why not? Java's good, Kotlin's good, it's all good. If you want to know more about Spring Cloud Stream in general, the project page is here. If you want to reach out to me, email works. Again, Twitter is best. Thank you for coming. And with that, I turn you back to Spring One. Stick around, enjoy the day, enjoy tomorrow, and go Spring.
Mark, thank you so much. I would have loved to have given you 2 hours, 4 hours, but we have other amazing presenters we have to get to. I will once again urge everyone to join the discussion. There's a nice, helpful little link right there. You can launch in and continue to talk to Mark, ask questions. I'm going to go out on a limb and say Mark will stick with us until he runs out of coffee. So hopefully he's got a full, fresh pot brewed there. So go ahead and continue to ask questions, and we'll continue that from there. We're going to take a short break, and then we're going to be joined by my good friend Victor, who I don't know if he's going to run us through a HIT workout or if he's going to talk to us about Confluent, but we'll see. We'll see where that leaves us. So we'll go ahead and take a quick break here, friends.